into the inside of the mitochondria. They pass through the, oh, there's a diagram from your textbook showing it taking place. But here they go. They pass through the outer membrane of the mitochondria and the inner membrane of the mitochondria, and now they are in the matrix of the mitochondria. So let's talk about our yield. For every pyruvate that went through this process, one NADH molecule was generated. But remember, there were 2 pyruvates that we got from glucose. So if we talk about what's our energy yield per glucose, it's 2 NADHs, one here and one here from the transition step. Where'd my score sheet go? Well, somewhere around here's my score sheet, but it's in your handout that that's the energy yield per glucose. Alrighty, and now for the Krebs cycle. So we've got these 2 acetyl groups being coated around by the coenzyme A's, and there they are in the inner compartment of the mitochondria. And so they move through the inner membrane of the mitochondria until they encounter this thing. And this is the Krebs cycle, which is sometimes called the citric acid cycle. Citric acid is one of the intermediates of the cycle. So remember, what are cycles? They are circular metabolic pathways. They're a group of enzymes that move molecules around circularly. But you always have molecules that feed into a cycle and molecules that get spun out of the cycle. Otherwise, there wouldn't be much point to it if nothing ever entered or exited. The molecules that feed into the Krebs cycle are the acetyl groups, and what spins out of the Krebs cycle are carbon dioxides. In other words, as these acetyl groups go through the Krebs cycle, they get more and more oxidized until both carbons in each acetyl group become carbon dioxides. There it is on this diagram. And here's from a textbook the full-blown version of what it looks like. Actually, I guess in this diagram they're not telling you the names of the enzymes, but of course each enzyme has its own name. But they are showing you all the names of the intermediates. You don't have to memorize the intermediates. I just want you to know what goes in and what comes out of the cycle. All right, well, let's watch it here. The first coenzyme A is going to deliver its acetyl group into the Krebs cycle, like that. Oh yeah, where does that coenzyme A go? Well, once it's delivered its acetyl group, its job is done for now, but it's actually going to go back outside the mitochondria and pick up another acetyl group from another pyruvate. So they're constantly shuttling in and shuttling back out of the mitochondria. And there goes the acetyl group. So each enzyme makes small changes in it as it in the functional groups of those carbons as they go through the cycle, and they're actually slowly oxidizing those carbons, and so you get high energy molecules captured along the way. There's an NADH that's captured at that step. Another NADH gets some high energy electrons out of that step. I think there's an ATP coming up. Oh, so now one of the carbons is fully oxidized as CO2. There's the ATP. Again, FADH2, which also carries high energy electrons, is there. And as that last carbon is oxidized to a CO2, you get one more NADH. So for each acetyl group that goes through, it gets fully oxidized to 2 carbon dioxides, and you get 1 ATP, 3 NADHs, and 1 FADH2. But of course, there was 2 acetyl groups you got per glucose, and so the actual yield per glucose is twice what I've listed there. Inner compartment mitochondria, acetyl groups into 2 carbon dioxides, and double all those yields I told you about. 6 NADHs, 2 FADH2s, and 2 ATPs. Good so far? Okay, let's see. Let's at least begin to talk about the electron transport system. Oh yeah, there's a figure from your book summarizing some of the parts of the Krebs cycle. Okay, now notice that at this point all our carbons have been fully oxidized. We start off with 6 carbons in glucose, 1 CO2, 2 CO2, 3 CO2, 4 CO2, 5 CO2, 6 CO2. It's been utterly completely converted to carbon dioxide, so we can't get any more energy out of those carbons. They're as oxidized as they're going to be, and yet we've only made 2 ATPs, and I promised you 36 ATPs, so it seems like I'm shortchanging you 2 ATPs. Well, here's the explanation. Yeah, up to this point we have only made 4 ATPs, but notice we've been making a whole bunch of these high energy electron carriers, the NADHs and some FADH2s. And so most of the energy from the glucose is not in ATPs at this point, it's in high energy electrons. There we go. And what's going to happen, what we're going to see is those high energy electron carriers are all going to bring their high energy electrons to the last step, which is called the electron transport system. And the electron transport system is going to change the energy in those electrons into the ATPs that we're supposed to get. Somebody explained it to me this way. They said the electron carriers are like checks for ATP, and the electron transport system is the bank that's going to cash them in. And so all those electron carriers converge on the electron transport system. Let's look inside here. Most of those high energy electron carriers are there in the inner compartment because that's where the Krebs cycle is, and that's where most of them get generated. And trek over, look to the side here, and zoom in on the inner membrane. And I'm just going to use this region of the inner membrane to show you the electron transport system, but in real life, the electron transport system of the mitochondria is all throughout the inner membrane. There are the phospholipid bilayers of the inner membrane and outer membrane. And there we go. There's the electron transport system. Remember, electron transport systems are molecules and membranes that carry electrons. Some of them are proteins. One of them is a non-protein, but they all can pass electrons to each other. Here we go. All right, maybe I'll just summarize it for now. The electron transport system, the inner mitochondrial membrane, and it's going to make ATPs using the energy from those electron carriers. Let's quit right here. The exit quiz is a little bit bigger than normal today. So let's finish this up on Monday.